Why are planets like Tatooine so rare? General relativity explains the scarcity in binary systems.
Although most stars form in pairs and almost all appear to have planets orbiting them, worlds that orbit two stars at the same time, like the planet Tatooine from Star Wars, with its two suns in the sky, are extremely rare.
Of the more than 6,000 exoplanets confirmed to date, the vast majority discovered by telescopes like NASA's Kepler and TESS, only 14 orbit binary stars, that is, circumbinary planets. There should be hundreds, but the reality is quite different. Researchers from the University of California, Berkeley, and the American University of Beirut have proposed an explanation. Einstein's theory of general relativity plays a decisive role in this scarcity. In binary systems, the two stars generally have similar masses and orbit each other in elliptical trajectories. A planet orbiting the pair of stars experiences constant gravitational perturbations, causing its orbit to rotate slowly, a movement called precession, similar to what happens to the axis of a spinning top. The orbits of the stars themselves also undergo precession, but in this case, the main factor responsible is general relativity. Over time, tidal interactions between the stars cause their orbits to gradually slow down. This accelerates the precession of the stars, while the precession of the planet slows down due to the weakening of gravitational influence as the stars get closer. When the precession rates equalize and resonate, the planet's orbit becomes extremely elongated. It gets very close to the stars at one point in its trajectory and very far away at another. In this situation, two things can happen: the planet is ejected from the system, or it gets so close that it suffers a gravitational rupture, being swallowed by one of the stars or torn apart by tidal forces. This process occurs relatively quickly, in tens of millions of years, within the long lifespan of billions of years of stars. Therefore, nearby planets in compact binary systems, with orbital periods of about 7 days or less, practically disappear.
The few circumbinary planets detected are generally located just beyond a zone of instability around the stellar pair, where the interactions of three bodies, two stars and the planet, make stable survival impossible. Forming planets exactly at this edge would be like trying to build a snowball in the middle of a hurricane. Although planets in binary systems exist, most are too distant to be detected by current transit methods, which look for the periodic dimming of starlight. Thus, what we see is a great rarity of worlds with two suns, especially in the most compact systems. General relativity, which already explained the extra precession of Mercury's orbit more than a century ago, shows here once again its subtle, yet decisive, impact even in simple planetary systems.